All right, so we're looking at using the converses of the transversal theorems that we worked on last time, where we just exchanged the hypothesis and the conclusion. Last time those transversal theorems read, if we had parallel lines cut by the transversal, then these angle pairs were either congruent or supplementary. Now we have, if two lines, we don't know what the relationship is, cut by transversal, have these angle pairs in this relationship, then the lines are parallel. Okay, so notice that we have the same kind of setup from the last time. We have corresponding alternate interior and alternate exterior being the congruent ones, and consecutive interior and consecutive exterior being the supplementary ones. So we're going to be referring back to this as we're doing the examples on the study guide in order to help explain why we're setting up our algebra equations the way that we are. So off to the side and to our study guide. Thing to note about the study guide is that box at the very top is kind of like the shorthand to help you remember which angles are congruent or supplementary, but they don't tell you the name of the theorem. And for your explanation, you have to have the name of the theorem. Okay, so make sure you have your notes out. Now there's not very much room at the bottom, numbers 1 through 6, in order to show your work, so please do the example scratch work on the back side of your notes so that you have plenty of room. I'm going to do it as a little scratch sheet of paper. All right, pick a number between 1 and 6.
2.
2. We'd like to see number 2. All righty, going to zoom in nice and close here. There it is, number 2. We're trying to figure out what value x needs to be in order for L and for M to be parallel. In order to figure that out, we're looking at this line and this line needing to be parallel. That makes this my transversal. So in that setup, the two angles that we have are what kind of angles? Corresponding, alternate interior, alternate exterior, consecutive interior, or consecutive exterior. Alternate interior, they're on different sides of the transversal, and they are both in between the lines that we hope are parallel. So we can state that by the converse of the alternate interior angle theorem, please spell yours out all the way, especially on your homework assignments. Thank you. That if these angles are congruent, then the lines will be parallel. So we need to figure out which value of x makes these angles congruent. What does congruent mean?
Same size.
Same size, same shape, which means these measures need to be equal. And if these measures are equal, whatever value of x makes that happen, that's the value of x that makes those lines parallel. Yes, ma'am. The converse of the alternate interior angle theorem. I abbreviated like crazy. Sorry. All right, so since you said they needed to be congruent in order for those lines to be parallel, and for them to be congruent, their measures need to be equal, I'm going to set up my algebra equation that way. Measures are equal. And I'm going to solve this equation for x. And whatever value I get from that, that's the value of x that makes those lines parallel. All right, what do I need to do? Move the 4. The 4, just the 4 or the 4x?
The 4x.
The 4x. All right. Moving the 4x. Hopefully this feels really comfortable right now. All right, now what? Now what?
Oh, divide 2.
Divide by 2 so we can get the 2 away from the x. We're dividing by 2 because here in this first step we were multiplying by 2. All right, so x needs to have a value of 10 in order to make those lines parallel. Make sense?
Yes.
All right, be careful because there's going to be some where it's supplementary. Do you want to try to find one where it's supplementary to see the setup on that one? All right,
Yes.
tell me which one that is. through the examples on our study guide, 1 through 6. 4. All right, 4 is the one where they're going to end up being supplementary. So let me zoom in on 4. Are they?
No.
No, they're going to be congruent again.
So 1.
1, those are also congruent. Oh my goodness, this doesn't have a single one where they're supposed to be supplementary. That's not bueno. All right, let's look at our skills then. Number 1 on the skills, you said? Or number 5 on the skills, rather?
Yep.
All right. So they're supposed to be supplementary in order for L and M to be parallel. For the angles to be supplementary, what do you do to their measures? What does supplementary mean?
Equals to 180
E-
degrees.
Equals to 180 degrees. And what do you do to get it to 180 degrees? Do you add, subtract, multiply, or divide?
Add.
Add. So we're going to add the measures of these two angles and have it equal 180. Here's the first angle, plus here's the second angle. That equals 180 degrees. And that's the setup on the equation when they're supplementary. And this is what you'll solve for x, and when you're done, you'll have a value of x that makes those two angles supplementary, which then in turn makes lines L and M parallel.
Yes.
Do you need me to work through the algebra on this one?
Yes.
Yeah?
Yes, okay.
What do I do first?
Subtract 6 from 30.
Okay. Then what?
Subtract 6.
Then what?
Divide by 2.
All right. Feel okay? All righty.
Chris, do you want us to show all of this when they're solving them?
Yes, we need to see every single step, and most importantly, you need to show which theorem or postulate, converse thereof, that you used in order to start your equation. So for this one, I used the converse of the alternate interior angle theorem. That said they were congruent, so I was allowed to set the measures equal, and then I did all my algebra.
5 is which one? What theorem did we use?
I don't know, what theorem should we use on number 5? Are they on the same side or are they alternate sides?
Same.
Same side. So your choices are corresponding or one of the consecutives.
The interior.
Consecutive interior.
Alright.
Okay. All righty. Any other questions? Thank you very much.